the third method that we're going to look at for solving a two-variable system is going to be what's called elimination or addition. And so the concept here is we're going to use addition to allow us to eliminate a variable. So kind of the process that we're looking at here is we want to get all of our variables on one side and the constants on the other. Then we're going to figure out what variable we want to eliminate to get rid of. So a couple things we want to look for is we want to have variables that are already in opposite signs. So the idea here is we want to have 3x and a negative 3x, or a 12y and a negative 12y. So if they're already in opposite sides, that kind of does some of the work for us. The other thing is if we happen to have variables that have 1 as a coefficient, those are quick, easy ones to get to match up, but we may have to do some sign stuff. Now, once you get the same amount of a variable, but in opposite signs, so again, a positive 3x with a negative 3x, something like that, and you are allowed to multiply either line or both lines by a constant if you need to make that happen, you're going to add the two resulting equations and then solve for the variable. And similar to what we saw in that substitution method, we have to go back and solve for the other methods. Now, pros and cons. Pros, you don't have to deal with fractions. You can keep everything in whole value, integer value type things. And if you get kind of an ugly solution, then you can do it twice. And we are going to look at one of those. Now, the con, you may have to multiply both lines in order to be able to eliminate the variable. And we'll kind of see how that process is through. So this first one that we're going to look at, we've got 5x minus 4y equals 9. And I've got x minus 2y equals negative 3. Okay, so we're going to take a look at this one. Now, I don't have anything in opposite signs because both my x's are positive and both of my y's are negative. But I do like the fact that this is a singleton x because I can very easily multiply this entire line by negative 5 so that I have a 5x in the top one and a negative 5x in the bottom one. So rewriting the top line and then distributing through the bottom. So I've got negative 5x, positive 10y, positive 15. I can now add these two lines together. Now, the whole reason for doing this is this 5x minus 5x will cross off. So I've got negative 4y plus 10y is 6y, and then I have 9 plus 15, which is going to be 24. We'll then divide by 6. And we get that y equals 4. Now I can take this and plug it back up anywhere I want to. I'm going to plug it into this equation right here. So I've got x minus 2 times 4 equals negative 3. So that's x minus 8 equals negative 3. I'm going to add the 8. And I get x is 5. Now, even though I found y first and then x, when I write the solution, I'm going to write x then y, so 5, 4. Now, let's take a look at another one. So I've got 4x plus 5y equals 3. 2x minus 3y equals 7. Okay, so with this one, I do have that the y's are at opposites. So now, but I don't have anything that's a 1. So I look at 4 and 2, and I think about their multiples going up. So 4, 8, 12, 16, 2, 4, 6, 8, 10. And I look for the first place that they match. The first place that they will match is at 4. Okay, over here with the 5 and the 3, the first place that they're going to match is at 15. So I'm going to make my x's match at a 4. So this one's already a 4, so I don't have to change that one. I do need to multiply by a 2 to get this up to 4. Since they're both positive, I do need to pick up a negative on that second multiplication. So rewriting first line. And then distributing, I'm going to have negative 4x plus 6y equals negative 14. And here we go with add again. The 4x and the negative 4x, when you combine them, will cancel off. 5y plus 6y is 11y. 3 plus negative 14 is negative 11. Divide by 11. I get y is negative 1. Again, I'm going to plug this back into one of the equations. I'm going to go in for the second one. So I've got 2x minus 3 times negative 1 equals 7. So I've got 2x plus 3 equals 7. I'll subtract the 3. 2x equals 4. Divide by 2. I'm going to get that x equals 2. So my solution is x, y. So I've got 2, negative 1. Now, let's take a look at one of these where we get kind of what I was talking about, an ugly solution. Okay, so we're going to take a look at 2x equals 7y minus 17 and 5y equals 17 minus 3x. Now, the first thing that I'm going to do is get all of my x's and y's pushed over to the same side. So I'm going to subtract this 7y. Okay, and then I'm going to add this 3x on this second line. Okay, so now when I look at this pair, okay, I go with 2 and 3, and I think about where do they match up through their multiples, and they're going to match at 6. And then I've got 7 and 5, and they will match up at 35. So I'm going to make the 2 and the 3 match. So I'm going to rewrite down here so I can show you where I'm going with my math. Okay. Since I want them to match at 6, I'm going to need to multiply this one by 3 and this one by 2. And one of them needs to be negative. I'm going to choose this one to be negative because I kind of want to get rid of some of those other negatives through there. Okay, so now distributing, I've got negative 6x plus 21y equals that's going to be 51. Okay, and then 2 times 3 is going to be 6x. 2 times 5 is going to be 10y. And I've got 2 times 17 is 34. So we're going to add those two. Again, the x's will cross off because we made that match happen. I've got 31y equals 85. Divide by 31. I got 85 over 31. Now that will not clean up. It will not get pretty. Okay. So I could still take this and plug it back into an equation, and I could get a solution for working the x's. But I'm not super friendly with wanting to play with the fractions. So I'm going to reset my equations. And now I'm going to make my y's match. Okay. So we'd already mentioned that they're going to match at 35. They are already in opposite, so I don't have to worry about that. So I need to multiply this one by 3 and this one by 7. Okay. So I'm going to get 10x minus 35y equals negative 85. 7 times 3 is 21x plus 35y equals 119 for that one. And again, we're going to add. So we've got 10 and 21 makes 31x. The y's cancel off. It's going to be positive 34. And then again, we'll divide by 31. So I've got x equals 34 over 31. Okay. It does instill a little bit of confidence in me that I do have the same denominator. So if I was going to write this as an ordered pair, there is my x, y in order. And again, this is what I was talking about with if I get a solution that's not exactly pretty or that will easily work with my equations, then you can just reset and make the other variable eliminate so that you can get that solution.